Hello. So we will start with week 7 in a few minutes. Just checking in case anybody else is joining. Okay, so let's get started. A few people might keep joining. So first things first, if anybody has any questions from week 4, week 5, week 6, we can discuss that first. And then I'll move to week 7. Any questions from the previous assignments or any other problem you have in the theory for the previous weeks before week 7? No? Okay, great. So, what is this? The transcript or lecture material? I don't think there is any lecture material for the course, uh, itself. Like whatever I discuss in the class, that I am uploading already. For the course itself, I am not sure if there are any there's any reading material or anything. I will check, but I don't think that there is. So if there is a link, then okay, I will ask them. Can you please also post this in the discussion forum? There is a Google discussion forum where participants can post their questions or concerns and stuff like that. So, like if you post over there, it's like a bit easier to take up the issue. They can address it there, like they can answer you directly. Yeah, so I don't know, maybe there was a link. I'm not sure about it. Maybe earlier there used to be something. I have not seen it. Uh, so that's why I'm not aware of it. But if there is something, you can just post in the discussion forum that there is no link or that the link is broken, whatever is the exact issue. Okay, so somebody has posted questions in the discussion forum, but I don't know, I don't think that the person has logged in. So if the person logs in, I can kind of answer the question. Otherwise, yeah, otherwise I will let them be for now. There's a feedback form. I'm not sure if anybody is seeing actually. So it's better if you just post it in the discussion forum where the TAs can see it. The feedback form, I don't know who it goes to actually. I never see it. I never get the results of any feedback form. So I think the results of all the feedback forms, I think just go directly to NPTEL as far as I know. I'm not sure if they go to the concerned TAs and all. So just post all your any these administrative questions or even any conceptual questions. It's really just best to post it in the discussion forum where it is available for because sometimes they might just forget or they may not realize that something is not working. So or it may not be like you said, it may just be a website issue, the link is broken or something like that. So if you post it in the discussion forum, it's just easier to take it up with whoever is the person responsible for it, because sometimes we also don't know. Okay. Yeah, so last time we were discussing something and I'm not sure I answered it very properly, as in I think there is still scope for sharing a little bit more on that. I was talking about marginal utility and its ratio with price. And just give me a moment. Let me open that. Yeah. So I was talking about marginal utility and its ratio with price, and when you will consume how much of each good and stuff like that. And I remember answering it, but I know that I was not particularly happy with how I answered it. So I'll just go over it briefly once again. And if you have any questions about it, we can just then discuss. Okay, 1 minute, I've gotten logged off. Yeah. Okay, so for those of you who have only just joined, any questions from previous weeks? If you have any questions from the coursework of previous weeks, please let me know. I will discuss those first. Either the exercise like the assignment or what else is there? Or the coursework, like the concepts. So if you have any doubts, you can take some time to think over it. You can just type it in the chat box. Let me open that question which I had last time. Just like, I think I'll just read out the language from the question I had. So the question was something like, MUA by PA and MUB by PB, where A and B are two goods. That's all that was given. You weren't given anything about the preferences or the utility function or the nature or anything about these two goods. So this was the question, that if in this case, if it's not very neat. This case, if this is the case, then what happens? And of course, I mean, without any loss of generality, you can obviously understand what happens if it's the sign is flipped. So I think some people asked me about whether it's a corner solution in this case, and there was a discussion about whether the person will consume only good A, or they will consume more of good A and less of good B. So these discussions were like, I think we had these discussions last time, but I just wanted to clarify a few things. That somebody had asked me something about a common solution, and I unfortunately don't remember your exact question. So the thing with oh no, can you see my screen? No. Okay, hang on, some issue. Sorry, just give me a moment. My screen got disconnected. Yes, so what I was, I think I answered it very briefly, but what I didn't answer completely was that in the case of substitutes, perfect substitutes, or like, in your course content, actually, that's another second point, that in your course content, there's the definition of perfect substitutes is just when you have preferences like AX1 plus BX2 is equal to U, if we can say X1, X2. This is taken as perfect substitutes in your coursework. So if you get anything in your exam or assignment or whatever where they call it perfect substitutes, you should assume this general form, because that's the definition you guys have followed. But it just like in some books and some literature, they call these as substitutes. That's what I was addressing it as in the previous few classes. And x1 plus x2 is equal to, or ax1 plus ax2 is equal to u. This is what some people call as perfect substitutes. And if it is not the same coefficient for x1 and x2, then you can just call it as substitutes. So in coursework, I'm writing this just to avoid confusion. And this is how it's there in the literature in many places. So it's basically a slightly subjective definition, not a very clear definition like that. I didn't find any like that. So I'm just explaining this just to clarify, because I have said something different in some of my classes, and in your coursework, this is what you're calling it as. So forget about like whatever I have said, it's not exactly wrong, but if you have to take a decision in some assignment or exam or something, then just go with the definition in your class. That is probably what you will need to follow. Okay, so now coming back to the original question of ratio of marginal utility with price, what we were talking about was the case of perfect substitutes. And in perfect substitutes, I mentioned something like you will have, say, these are, say, your preference, indifference curves, and say, suppose this is your budget line, and in a different scenario, say, suppose this is your budget line, right? So green is one budget line for budget equal to I1, and pink is a different budget line for budget equal to I2. And these are indifference curves with values K1, K2, K3, X1, and X2. Okay, so in this case, what the unique situation in this case is that this is your function, right? U of x1 comma x2, let's assume the general form for now, ax1 plus bx2. So what is del u by del x1? It is a. Similarly, del u by del x2 is b, which means it is constant marginal utility. So it's not like if you change the value of x1, the value of, let's call this as mua, because that's the notation I've used. So basically MUA by PA is equal to what? It's constant. It's decided by parameters. It's what? A by P, A. And similarly MUB by PB is equal to B by PB, which is also equal to constant. So, I mean, this kind of sounds like a fantastical scenario. Maybe in real life it happens like that or doesn't happen like that. I don't know. But in this case, the person will reach their optimal level of consumption immediately. There is no sort of path, like you are given 500 bucks and you have a choice between buying, say, I don't know what do people buy, grapes and bananas, and the prices are given to you, whatever the prices are, and you have 500 rupees, and depending on this value of A by PA and B by PB, you will immediately spend all the 500 bucks either on grapes or on bananas. There is no curve, there is no path by which you will reach that value of consumption or that value of either grapes or bananas. I don't know. Is it making sense? Is what I'm saying making sense? In this case, in the case of perfect substitutes, that is what happens. And why is that? Because say suppose I1 is the budget PA x1 plus PB x2. Say suppose this is the first green one, the green line. In this case, what we are seeing is that the values are such that if you want to stay at this level of utility, K2, U equal to K2, then you can optimize that value, or you can achieve that level of utility either by, there's no either actually. There is only one way in which you can achieve that level of utility. That is, K2 is the highest level of utility possible, right? For this person. for this person who has this budget line I1 and they're trying to decide between X1 and X2, the maximum level of utility possible for this person to achieve without violating their budget is K2, right? And there is only one way to achieve K2, and that is the corner solution, where you spend the whole thing on X2. You don't buy any, and you don't even buy an iota of X1, right? Similarly, if I2 is your budget line, the prices and stuff are such that I2 happens to be a budget line, which is basically flatter than your indifference curve, then what happens? Then again, there is no two ways of achieving the highest level of utility possible. Now see, again, I2 is still on that same utility level. It is still achieving that utility level equal to K2, right? Again, K2 is the highest level of utility possible. Right? And that is achievable only in one way. There are no two ways of achieving it. There is no like series of bundles by which you can achieve the utility level of K2. There is only one way, and that is if you spend your entire income on X1. So there is no path, there is no lapse of time between you getting the budget and then spending it. You know all the prices, you know what is the highest level of utility you can possibly have, because you know all your preferences. So you will immediately spend the entire budget on X1. Now this is the case of perfect substitutes, and in this case, this kind of a scenario happens, this kind of a corner solution happens because A, B, all of these are fixed. It's linear preferences, and A and B you are already it's already given to you, and you can optimize it in only one way because it's linear, right? So in this special case, you get a corner solution. That's why somebody was asking me, and I think that was kind of like your question, that if you have some situation like this, then will the person spend more on good A and less on good B, or completely everything on good A and nothing on good B? So in the general question which I took up in the class, nothing is given about the two goods. That is why that is not the universal answer, what you were saying, that they will like spend it entirely on good A. But if these two happen to be perfect substitutes, then in that case, yes, you will spend your entire budget on good A and nothing on good B. But if, say, suppose you have a different kind of utility function, utility function can be any kind of utility function. So say, suppose you have something like x1 cube and x2 like that, right? It's not even quasi-linear. It is just some new function, some weird function. Then in this case, what is del u by del x1? It is 3x1 square x2, and del u by del x2 is just x1 cube. And prices, let's say prices are p1 and p2, or let's stick with pa and pb only, since that's what we're talking about. So in this case, mua by pa is equal to 3x1 squared by x2 by pa, and mub by pb, or let's call this 1 and 2 for now. Then you have x1 cube by pb. Now pa and pb are given, but this value of mu1 by pa, mu2 by pb, this is changing continuously with every time you change the value of x1 and x2. So as long as you have mu1 by pa is greater than mu2 by pb, what will you do? You will consume more of a. Okay. but you will not consume 0 of B unless there is some special scenario again where you arrive at that kind of a solution. But it's unlikely that you will be spending 0 on B. So what is mu1 by PA, by the way? It's 3x1 squared x2 by PA if this is greater than x1 cube by, since x1 is a positive quantity, and if I eliminate the corner solution, there's one corner solution which is like both are 0. For x1 0, both utilities are 0. So x1 0 basically gives you 0 utility. So you cannot have the corner solution in this case. But say suppose I take this as 3x2 by PA and x1 by PB. Now that's correct, right? Yeah. So in this case, now it's a linear situation, right? You will, as long as x2, 3x2 by PA is greater than x1 by PB, what will you do? You will consume 2, good B. No, sorry, good 1. What am I? Sorry, my. See, remember, this expression is mu1, even though this has x2 in it, and this expression is mu2. Okay, consume more of good 1, and then you will of course reach that value where this sign will flip. Okay, this will become equal at some point, and then it will change. Now, I'm not working out this example because it's a slightly complex function, and it's not something you're going to, hopefully you're not going to get a function like this in your test and all that. But it's just to illustrate that this will not always be a case of corner solution, and it will not always be a case of you will have one constant value. So if it's not a case of substitutes, then you will have to see what the utility function is, what the values of marginal utility are, and what what your function basically comes out to be. So even if this was not this complicated function, even if it were just something like x1, x2, then even then del u by del x1 comes out to be x2, and del u by del x2 comes out to be x1, right? Again, you will have this kind of a problem in the end, where the x2 figures in the marginal utility for 1, and x1 figures in the marginal utility for 2. Okay, am I making any sense? Or am I just going on talking to the screen and it's not making any sense to anybody? Did this clarify something, or did it make it more confusing? Make sense? Okay, yeah. You were, I think, the person who was asking me the question, so that's why I answered. The question which I answered, another question which you asked, I don't know if I misunderstood. What I explained to you about linear programming was if there is some other additional constraint on the values of x1 and x2. So what we have taken here is a simple case where all we know, there is a very simple question like that, which I think I included in my assignment, although it's not really a constraint, but still. So in this kind of a scene, even in the case of substitutes, there can be some other constraints on on the combinations or the total value of good, like maybe you have some constraint on x1 has to be between 2 and 4. Oops. Between 2 and 4, or x2 has to be between less than 7, something like this. So you won't get these kind of examples, so don't worry about it. But if you do, then that is the situation where I was explaining that you will need to use some, like not anything very complex, but you will need to use some basic linear programming for that, for the optimization problem. For the situations which you will get, most of them I think don't even actually need to use optimization. Most of them you can just solve with marginal rate of substitution, because this whole thing in changing the values of x1, x2 keeps happening, adjusting until at optimal point, at point of optimization, these both will eventually be equal, unless it's a corner solution. So then we're not talking about the corner solution. If it's not a corner solution, then you will have mu1 by pa is equal to mu2 by pb, such that let's write x1, x2 are greater than 0. Okay. Okay. So um, let me open the questions for this week. 1 minute. So any other doubts from this week and a previous week? Okay, you can see my screen, I hope. Okay, you're asking solution for question 3. Let me see what is question 3. 1 minute. So I think you're asking for question 3 from week 6, right? Okay. Which of the following utility functions represents perfect complements? That's the question. Uh, is that the question you were asking about? Is that the question? Week 6, question 3. That is submission is over, right? Yeah. I forgot to change the numbering of the week. So, oh, from my slides. Okay, okay. Hang on, let me open that. I have closed my slides. Let me just open my slides. Give me a moment. Week 6 and question 3. Okay, let me just get back to you on this. I have to look up the answer. It's not saved somewhere. I will give you the answer in the break. I don't have it right now. Actually, I had solved it. I mean, I had it on a paper, but I haven't brought that paper to class. So either I will answer it at the end, in the middle, in the break or sometime, or I can just post the answer on the along with the content materials, if that's okay. Yes, okay, yeah. So I don't know if the answer is in the book. I solved it, but I think I forgot to bring that paper, sorry. So if I don't have the paper here and it's taking me too much time, then I'll just post the answer on the in the same folder where I upload the slides, basically. Okay, let's go to this week's questions. Okay, so I hope you can see my screen. Hi, please. Yeah. Okay, so this is the first question. I'll give you a few minutes to read the question, to understand the question, and then I'll go step by step for each one right here. Okay, so what will we do here? First, like let's do the first part of this. So what are we going to do here? How will we go about it? Did anybody try solving it? I'm not sure what happened. I'm already connected. So I think the share screen stopped, right? You can't see my screen, I'm guessing. Are you able to see my screen?
Question is not visible.
Okay, just give me a minute. Let me open it again. Let me try it from here. Okay, in the meantime, um, yeah, I'm just connecting this. In the meantime, did anybody try solving it? How will we go about it? Ideas, thoughts? No? I'll just share a question again. I'm just having trouble logging in here. Okay, you posted something in chat. Um, so we'll come to that. First, we just the first part is just asking how much is the consumption before any sort of price change. We just share the question once again. I think the question is gone. So yeah, so the first part is just asking what is the consumption of potatoes and rice. So say it's given that the price of potatoes is $0.5 and you can assume it's per kg also. I missed out that part. No, it's not per kg, per potato, or it should actually be. It's a very funny thing. I mean, you don't buy potatoes per potato like that, but that's how the question is given. So there's nothing we can do. So just for this particular, forget about preferences and utility first. In this part, we are not really assuming there's nothing special given about preferences. So in this case, like the function is not given, but it's just given that you're choosing solely between rice and potatoes. So what is not given is usually not given because you don't actually need it. So just forget about that part right now. This just trying the question is, I think, aimed at illustrating something. So just can you just solve for it? What is the initial consumption of potatoes and rice? No, nobody is answering. Okay, let me solve it. So this is what we know. The total income is $30. Mm, no, so it's asking, the question is asking you per 10 days. Okay. A potato for every 10 days because the budget given to you is for every 10 days. For every 10 days, this is the budget. And you know that she has to eat 2 potatoes per day. That is given to you, which means in 10 days, she's going to eat how much? She has to eat at least 20 potatoes, right? It's not a very complicated problem. It's just you're not used to thinking in this direction. So you're getting a bit confused, but I have taken the language from the book. It's not my language. They've given um sorry 10 days. So somehow they have given the problem like that income is per 10 days, not a week and all that. So you just have to go with that oddity here. So 20 potatoes cost how much? $10, right? So she's going to eat $10 worth of potatoes, and the remaining is how much? $20. Price of rice is $10, 2 kg of rice. Is this clear? Is there any confusion about this? This is simple, only budget constraint. There is no preferences and utility so far. This is only a budget constraint question. Did you understand the structure of the question? She's eating 2 potatoes per day, and she's going to consume for 10 days. You have the budget for 10 days, which is $30. So since the preferences are not given, you just go with the minimum amount of potatoes she's going to consume. Once you solve it, I think it may become clear why the preferences are not given. But you have potatoes at like $0.5 per potato. So 20 potatoes is what? $10. She spends $10 on potatoes. How much has she got left? $20. So in $20, how much rice can she purchase? 2 kgs, because it's $10 per kg. So you have initial consumption, you can say x1 comma x2 is 20 comma 2. This is your initial consumption. Is this clear, or is this confusing somehow? It's not a usual type of question, that I agree, but it's just simplified it. They've not introduced, not talked about utility and preferences, just because they're only talking about budget constraint right now. Okay. So see, in some questions, if budget constraint is not, if utility is not given, utility function is not given, you just solve it like a budget constraint problem. Okay, you don't have to worry about why this is not given, why that is not given. If it's not given, most likely you don't need it. That's why it's not given. Okay, now let's come to the second part. Uh, and the reason why I picked this question first is because it's a slightly simpler setup. We can come and we can talk about Marshallian and Hicksian demand and all that, but I wanted to just introduce some concepts a little easily first. So in this question, we are not worried so much about yes, so you're asking me about we're fixing it. That is because she's eating the bare minimum number of potatoes, and the rest she's eating is rice. So she's spending the whole. If you are given preferences, you can optimize over that. But because you're not given any preferences, that is why we are taking just whatever those bare minimum number of potatoes she needs to buy. That is how the question is set up. So question, I think, from Pindyke and Rubenfield. Okay, see, if you just go with what is given, in the end, you will probably be able to make more sense of it. For now, let's just take it as that. Okay, can I go ahead? Okay, I'm hoping this is fine. So let's just solve it again using the same kind of principle. See, when you were doing budget constraint, this is only what you were doing, right? Now we are getting confused because we are feeling confused about how much of this and how much of that. But when we were doing that chapter on budget constraint, I think it was chapter 4, this is only what we were doing. It's just a simpler question, that's all. Okay, the part B. Now, if the price of potato increases to 1.25, then what happens? Can you just quickly solve it? It's not like a very big question, actually. So if the price of potatoes increases to 1.25, what do we get? Yes, you get 20 potatoes and half a kg of rice. Exactly. So let me just write this down. This Okay, so now in this, what we will try to do is we will try to decompose this and see what we can see based on this, what we have just calculated. What we just calculated is that we know the budget is fixed, $30. Income is fixed. What we have is that with the change in price, is the consumption of potato increasing? It's not increasing. It's fixed as 20, and the the quantity of rice consumed is actually decreasing. So I think the point the person wanted to, let me just open that question if I can find it. So the question basically is just asking you whether potato is a normal good or some other special kind of a good. So what do you think it is? They've actually set up the question like that, so I can understand if you're feeling a bit confused about it. I think the author wanted to just emphasize that point. Let me see if I can find the original question again. You can actually, no, it will come out to be the same. Yes, that is it. That's the question. What kind of a good is potato? So, what do you think happens here in this case? So, what I think what the person, what the author is trying to ask you is that, with the change in price, what is happening? The price is increasing, but the consumption of potato is not reducing. And again, I know that's how they've set up the problem, but what they're trying to illustrate is that if you see that there is no change in the consumption of the value, even though the price is increasing, then what happens? What is the income effect and substitution effect here? Is it positive? Is it negative? What is it? So what happens in the case of increase of price normally? Normally meaning, what are the two effects that happen? Income effect and substitution effect, right? Substitution effect is usually what? Negative, right? I don't know. Am I making sense? So I think people are getting confused. So let me leave this question. The basic point was that in this particular example, income and substitution effects are cancelling each other. And that cancelling each other only happens when both are of opposite signs. It's a slightly tricky question in that sense. You had to figure that part out. That the quantity consumed is not changing. This is also 20. This is also 20. I have skipped one part of the question in which you again calculate the value of the amount of potato consumed for price equal to $1. So you can calculate it and see it comes out to be 20 itself, obviously, and rice will be something lesser. So what we are trying to illustrate is that the amount of potato consumed is not changing, and the main key point was not any of this calculation per se, but that if the quantity consumed for a good remains the same, even if the price is going on increasing, then that means what? that the income and substitution effects are working in opposite directions. And when they're working in opposite directions, that means that good is a given good, right? So that is all the point was. Is this part clear, or is it still confusing? So only in one case does this happen, and that is when you know okay, so let's take a short break here. I'll just share the next question, and we will discuss the next question after that. Let me share it from here. I think that might be easier for you. Any questions on this discussion? No? Okay. So this is, I think, probably a slightly more familiar kind of a question. So let me leave you with this. Oh, oops. Sorry, I'll just share it again. Oops, my screen has gotten hanged. If you're finding the previous question confusing, you can just ignore it. I think I just wanted to illustrate a point, but if it's confusing you, you don't have to worry about it. We can just go to the next question, and you can just start solving it. I will take a few minutes, and then I will discuss it in the class. Okay, so hopefully this is a simpler question. Um, I think one person has solved it. Okay. Yes, I think your answer is correct. Anybody else? Has anyone else solved it? Okay, then let me take a shot at it. So I know most of you solve it using the MRS equivalence, which is why I just for the purpose of a little bit of, you can say, maybe variety, and also because of my personal preference, I will solve it using the optimization method. If you're getting a different answer using MRS, then you should check your method, or I don't know. I don't think I have made a mistake, but you can always double check it that way. That's kind of like a good way of checking. So we are given u of xa, comma xb is to be xa xb, and we are given the prices as p a is equal to 1, pb is equal to 2, and we are given income as 40. So PAXA plus PBXB is equal to income. Let's just write it, say this part A. This is 2, so XP is equal to 40. This is equation 1, this is equation 2. Now what I will do is I will convert utility into one variable. So I'm going to just write it as a function of XB. Then do it the other way around. Also, that's also okay. 40 minus 2 XB, right, from 1 and 2. Then you just optimize it using differential calculus. This is 40 minus 4 XB is equal to 0. This gives XB equal to 10. Therefore, XA comes out to be 20. Okay, this is pretty straightforward. Okay, so this part is like not a big deal. Now, what I will do is, again, I will solve the same question using the same method for part B also. But if anybody has any problem with it, I really would prefer it if you can tell me now, because I'm just going to solve it the same way for part B as well. But if you're not clear about it, we can. Sorry, you're asking me to repeat. Can you tell me exactly what part is not clear to you? Which part you want me to repeat? Okay, so what I've done here is, if you're finding this confusing, you can use the MRS method also. What I have just done is I have taken the function, this is given, XA into XP is U. I have written the budget equation, which is 1x1 plus 2xp equal to 40. This is the budget equation. And combining 1 and 2, this is 1. I've just taken the value of XA from equation 2 and plugged it back into equation 1. That's all I've done. So where here XB into 40 minus 2XB is nothing but taking the value of XA from equation 2. You simplify this further, what do you get? XA is equal to 40 minus 2XB. Now you just plug this back into equation 1. You get this value. And then, like any other maximization or optimization problem in differential calculus, now because it's only one variable, so we can do that. We don't have to worry about two variables. We've already taken care of the budget constraint by plugging in the value of XA. So Then I just differentiate with respect to xb. I get this equation here, and you solve it, you get xb, and then you plug the value of xb back into the budget constraint and you get xa. So you can just do the same exercise all over again, or if you want, you can solve it using the MRS, um, the MRS equation. That is also, I mean, so now because we have a very simple situation, and this was the first case, a very simple situation in the second case. Second case is, I think, just xa plus xb is equal to 40. This is a new equation because the price of bananas falls to $1, right? Yeah, so in part B, the price of bananas suddenly falls to $1. So now how many apples and bananas does Charlie consume? So now if you want, you can actually solve it using this, or you can solve it using MRS, but you can see it's a very, very symmetrical equation, xa plus xb equal to 40. For equation like this, generally when you solve it, xa will come out to be equal to xb, and what we will get will be xa equal to xb is equal to 40 by 2. So you can just solve it from here. You don't even need to do the whole thing. In exams, these kind of hacks help a lot because you have generally have less time. At least I do. I can't. I usually sort of take a lot of time in exams. So these kind of symmetrical things usually help a lot in, you know, situations where you have to solve it quickly. So just by symmetry, you can see that this is what it will solve out to be. The third part is the more important part, that which effect do you think is more prominent here? Which, let me share the question. Yeah, so I'm just sharing the slides again. So which effect is dominant in this example? And if you can, if possible, if you can explain why. What is exactly happening here? So I know one person answered and you answered correctly. So what is happening here? The price of bananas is falling to $1, right? And consumption is doing what? Consumption is, so initially we had, where was the solution? Yeah, so initially we had 20 apples, 10 bananas, and in the second case, after the price drop, consumption of bananas is increasing, right? From 10 to 20. It has doubled. So, see, I mean, if you want, I can, we can solve it and we can solve out the decomposition of income and substitution effects, and we can see which is what value, all that, blah, 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 which I think, I hope you will be comfortable with. I will cover a little bit more of that. So I will upload a little bit of notes on that for some of these questions after, along with these, along with the class slides and class notes, I will upload some of that also. But even without that, I'm just saying that, you can solve for all that. You can calculate the whole thing, but, or you can even draw the diagram and do the whole thing. But just by running an eye over it and just seeing what is happening in this question, what you observe is itself usually enough to understand the just this part. So what usually happens when price falls? What is the case? If the consumption is increasing, then that means substitution effect is dominating. Because for income effect to dominate, first of all, it usually happens when that good is making up a huge part of your income. I know the previous example was a bit confusing for some people, but if you saw in the previous example, the person was spending like a good chunk of their income on just potatoes, right? And they were consuming like 20 potatoes and just half a kg of rice or 1 kg of rice, something like that. So generally, first of all, income effect happens when you're spending, you're consuming way too much of one good as compared with the other. And that is one way of seeing it. But generally, if your consumption is remaining the same or falling, that is when income effect is actually coming more into place. I'm not saying there is no income effect. I'm just saying that the substitution effect is dominant because you can see that there is an increase in consumption with the fall in prices. And that happens only when substitution effect is dominant. So let me just write this down. So as an exercise, I will encourage you to solve for substitution. What is the, the decomposition for substitution effect and income effect, and calculate the values and see which one is coming out to be how much. And then, of course, it's a lot more convincing when I say that substitution effect is dominant. I will upload that. So in B, why we have considered, that's what I was explaining, that then it becomes a very symmetric problem. If you want, you can solve it, but just looking at the problem, you can see that X1 and X2, they're both having the same prices, and your preferences are also linear. So X1 plus X2 is equal to 40. Like it's a symmetric problem. So generally, you will split your income into two halves. You're getting the same level of utility from two goods, and the price of the two goods is the same. It's a case of perfect substitutes, right? And in the case of perfect substitutes, if there is no other constraint or no other factor, generally you will split your income into half, right? And in this case, I mean, you can also see that the utility function is also just xa into xp. There is no other number, nothing. I'm just like giving you a shortcut. The shortcut applies only if the problem is completely symmetrical in every way, which this problem is. So otherwise, I mean, if you want, we can solve it again. It's just, if you can solve, if you want me to solve, we can solve the, what we have now is x1 a plus xb is equal to 40, right? U, oops, u is xa into xb. We do the same thing. We plug in the value of any one. We can do xa also this time. 40 minus x, sorry, xa, right? Okay, this time I'm just substituting for xb instead of xa, so it's less confusing. So du by dxa, we again differentiate because now we have only one variable. 40 minus 2, xa equal to 0, xa is equal to 40 by 2 is equal to 20, xp is 40 minus 20 is equal to 20. So your new consumption set is 20, 20. I'm just saying that instead of, you can, of course, you can do the whole calculation. It's not a very long calculation anyway, but just that, when the problem is generally, if you solve a lot of these problems, you will sort of develop an intuition for it, that if it's a completely symmetrical problem, it will just come out to be half. Okay, so let me go back. Okay. So this is your next question. And I think, yeah, I didn't bring that many questions today. I actually, all right, let me just mute myself for 2 minutes and I will let you read the question and go over it properly. And then we will discuss it.